Let's go through an example of completing linear regression by using the total squared error method. So the equation for the predicted y is slope times x plus y-intercept, where we can exactly calculate the slope and y-intercept using these equations here. So these equations will give us the slope and y-intercept for a linear line that minimizes the total squared error of our data. So let's come up with some data. So I measured the total number of hours that my puppy June sleeps over 6 given days. X is going to be day. So for day 1, June slept 5 hours. On day 2, she slept 3 hours. And then 8, 7, 5, and 8. So the first thing that we're going to do is calculate the sum and then the average of the x and y. So let's do this in our heads. So 1 plus 2 is 3, plus 3 is 6, 10, 15, and then 21. For the y column, we have 5 plus 3 is 8, plus 8 is 16, 23, 28, and then 36. And the total number of observations is 6. So n equals 6. So 21 divided by 6, I needed a calculator for this one, turned out to be 3.5. And 36 divided by 6, that one we know, and that will be 6. Great. So x bar is equal to 3.5. That's the average of x. Y bar is equal to 6. That is the average of y. So then the next part of our equation is we're going to, for each data point, calculate xi minus x bar. So for the first data point, it's going to be xi is 1 minus x bar 3.5 gives us 2.5, negative 2.5. Ooh, that's a little crunched in there. And then for the next one, it's going to be 2 minus 3.5, which gives us minus 1.5. 3 minus 3.5, negative 0.5. And on down the line, 4 is going to be 0.5. And since this is increasing by 1, we can see that we're actually just increasing by 1 each time. So I'll go ahead and jump ahead here, 1.5 and 2.5. Okay, now let's go ahead and do the individual yi's minus y bar. So yi minus y bar. So the first one is going to be 5 minus, this is the 5, minus y bar 6 gives us minus 1. And now 3 minus 6 is going to be minus 3. 8 minus 6, 2. 7 minus 6, 1. 5 minus 6, minus 1. 8 minus 6, 2. Okay, so we've now done the intermediate steps to finish this part, and then we'll also do this one here pretty soon. But first, let's go ahead. So this sum is multiplying the individual xi minus x bar times the individual yi minus y bar. So let's do this part next. Xi minus x bar yi minus y bar times yi minus y bar. And so we've already calculated the inside of this parentheses in this column and the inside of this parentheses in this column. So it's just this value times this value. Negative 2.5 times negative 1 gives us 2.5. Negative 1.5 times negative 3 gives us a 4.5. Minus 0.5 times 2 minus 1. 0.5 times 1, 0.5. 1.5 times negative 1, negative 1.5. 2.5 times 2, 5. Okay, so finally, with these columns, let's do one more. Well, we'll do xi minus x bar squared. So this one is just the values in this column squared. And this one I needed a calculator to do, so I encourage you to do that as well. I'm going to go ahead and just copy them over from what I've previously calculated. So it's 6.25, 1.5 squared, 2.25, 0.5 squared, that one we can do in our heads, 0.25, and again 0.25. 1.5 squared turns out to be 2.25, and 2.5 squared is again 6.25. Excellent. So now let's go ahead and do the sum sections. So we need the sum of this column and the sum of this column. So this let's try to do in our heads. So let's do 2.5 plus 4.5 gives us 7, minus 1, 6, plus 0.5, 6.5, minus 1.5, 5, plus 5 gives us and I'll put it in this sum row of 10. Let's try to do this one in our heads too. So 6.25 plus 2.25, that's 8.5. So this is a 0.5, so it's 8.5. After this one, it's gonna be 9. So we've got 9 here. So this is gonna be 11.25 plus, so it's gonna be 17.5. 17.5. I'll get rid of my intermediate additions there. Okay, great. So now we have actually done all the calculations we need to calculate m. So what is m going to be? So m is the sum of this column, which turned out to be 10. Okay, 10 divided by the sum of this column here, which is a 17.5. And that I can't do in my head. So let me check that one. It turns out to be a kind of an ugly decimal. So it's 0.57 and then a bunch of other decimals. So I'm just going to leave it at 0.57. And now let's do b. So b is equal to y bar. So that's 6. Y bar is 6. Minus the m that we just calculated. So that's 0.57 times x bar, 3.5. And this I already did in the calculator too. So if I keep all the digits from m, this actually turns out to a wonderful number. It turns out to 4. Nice and convenient. So awesome. So we have now calculated our y hat equation for this example. So y hat is equal to 0.57 times x plus 4. And this is our best fit trend line. Thanks.